When you are asked to predict the product at the cathode or the anode, the first thing to take note of is the state symbol. In the first four examples here, I have L in brackets. L stands for liquid, and that tells me that I have melted my ionic compound. If I've melted it, there is no water present. So for example, sodium chloride liquid, the only elements you've got present are sodium and chlorine. In copper bromide liquid, the only elements present are copper and bromine. That means when I'm predicting my products at the cathode and the anode, I've only got two choices. For every one that's liquid, there are only two possible answers. At the cathode, which is negatively charged, the metals always form at the cathode. Your metal will always be the first word. It will always form at the cathode. Metals are positively charged. They move to the negative cathode. Copper is my metal. It goes to the cathode. Magnesium is my metal. It goes to the cathode. Iron is my metal. It goes to the cathode. The non-metals, which is always the second word, they are negatively charged. They go to the anode. When I'm writing the name of the non-metal, I need to make sure I write it as it is on the periodic table. So it's going to be chlorine, bromine, chlorine, and bromine. I'm not writing chloride or bromide. It's important that you write the name of the element in full, that you don't just give the symbol, and that you definitely do not give a charge. When I'm writing my product, I shouldn't have a charge. When I look at the next four examples, I can see that they are all AQ. And that AQ tells me that they have been dissolved in water. If you're dissolving them in water, then in the first example, I've got sodium and chlorine, just like I had above. But I've now, for each of these, also got hydrogen and hydroxide ions. Okay, water is H2O. H2O can be split into H plus and OH minus. So as well as the elements that you've got in your compound, you've also got hydrogen ions and you've got hydroxide ions. This is going to affect your answer. For the product at the cathode, the metal, which is positively charged, will still go to the cathode. But now you've also got hydrogen, positively charged, that will also go to the cathode. But only one of these can form. It's either sodium or it's hydrogen. The rule is the least reactive always forms. Hydrogen is less reactive than every metal other than copper. So as a general rule, if it's aqueous and your metal is not copper, hydrogen will be the answer. This case, sodium chloride, it's aqueous. The metal is not copper. Hydrogen is going to be my answer. In the next case, it's aqueous. Copper is my metal, so copper will be my answer. In the next case, it's aqueous. Magnesium is not copper, so hydrogen will form. In the last case, it's aqueous. Copper is not my metal, so again, hydrogen is going to form. At the anode, you're going to get the same products as we had above. So again, it's going to be chlorine, it's going to be bromine, it's going to be chlorine, and it's going to be bromine. The rule at the anode is that the halogen will always form if the halogen is present. The only example they'll give you where you won't have a halogen would be if they give you a sulfate. So this example, copper sulfate, aqueous. It's aqueous, but my metal is copper, so copper is going to form. And at my anode, because I don't have a halogen, instead I'm going to get oxygen. Sulfate is this SO4 2-. You've got sulfur, you've got oxygen, and it's the oxygen that forms. So at the anode, you've always got a halogen, a group 7 if it's present, or you've got oxygen if you've got sulfate. At the cathode, if it's a liquid, you just take the metal that will form at the cathode. If it's aqueous, you need to look at that metal. If it's not copper, hydrogen will form. If it is copper, copper will form.